Alrighty, hey guys, this is the review video for exam 2. Okay, this right here, sorry, I went to the next slide. This right here, that's the calculator I've been using in my live sessions, okay, and the last video I sent out. So make sure that if you want to use it, this is the link for it, so you can pause the video and write it down or type it into Chrome. Alright, let's get going. So it says that Micah reads a 375-page book in 5 hours. Okay, we want to know how many pages per minute did she read. Okay, so I'm given time in hours, but I want minutes. So what I'm going to do is take those 5 hours and figure out how many minutes that is. All right, I have 5 hours and there are 60 minutes in 1 hour. So I'm going to multiply the two of those together. So I'm going to do 5 times 60. 5 times 60, right? And when you multiply these two, you get 300. So there are 300 minutes in 5 hours. So when I write my ratio, remember time always goes on bottom. So I have 375 pages every 300 minutes. Okay, so if I want to know how much it is, or how many pages you can read every 1 minute, remember you divide by 300 here and divide by 300 up top. So 375 divided by 300, I get 1.25 pages, or 1 1/4. So answer here is B. Guys, the number one mistake on this problem is forgetting to convert from hours to minutes. Okay, you have to do this step first. Please do not forget to do this step. Okay, for question 2. So it says a recipe asks for the following 3 ingredients be mixed together as follows. So add 1/4 of a cup of flour for every 1/4 of a teaspoon of baking soda and every 1/2 of a teaspoon of salt. So they give us 3 different ratios here. The question is saying which of the following rates is a unit rate equivalent to the ratio shown above? This is 2 teaspoons of salt per 1 teaspoon of baking soda. Okay, well, if I look at teaspoons of salt here and teaspoons of baking soda here, right, if I want salt on top, so if I have 1/2 over 1/4, if I want to go to 1, remember you divide by 1/4, so you're going to do the same thing up top, divide by 1/4. So I'm going to type this into my calculator, and I get 2. So that works. All right, so for every 2 teaspoons of salt, I get 1 teaspoon of baking soda. So what you really just want to make sure that you do here is just go through and check all of them. Notice that 1/4 and 1/2, that's a 2 to 1 ratio. All right, so here I have my circle and I cut it into fourths. Right, this is 1/4 of my, if we could call this a pizza, right? If I have 1/2, that's 2 of them. So if I take this half and pull it out here, right, 1/4 is half of a half, so it's a 2 to 1 ratio. So any of these that have a 2 to 1 ratio could be a possible answer. So this one down here, D, could not be because it says 3 to 1. So just read through them and double check and make sure that, you are adding the right ratios. You could also look at it this way, right? So this is 1/2 teaspoon of salt for every 1 teaspoon of baking soda, but the baking soda ratio, the fraction, is smaller than the salt. So salt should always be heavier. You should always add more salt than baking soda. All right, Ronald went to the store and bought 3 1/4 pounds of chicken breast for $15. What is the cost per pound? Remember, for this one, money always goes on top. Okay, money always goes on top. To solve this one, you can do this many ways. All right, I'm going to divide by 3 1/4. Divide by 3 1/4. All right, so if I take 3 1/4 and change this into a improper fraction, remember you multiply denominator times whole number and then add your numerator. So 3 times 4 is 12, plus 1 is 13 over 4. Okay, now the reason why I'm doing this is because what I'm going to do is I'm going to use my Desmos calculator. Okay, so I'm doing 15 and I am dividing it by this fraction, 13 over 4. And I get this long decimal here. However, since we're talking about money, I only need to look at this second number, which is the 1, right? That's because whenever you're talking about cents, you only have up to 2 numbers in cents, right? The highest number of cents you could have is 99 cents. So if I look at the number after it, it is a 5, which means this 1 will round up to a 2. So my answer for here will be $4.62. So right here. If you know that 1/4 is 0.25 as a decimal, you could type in 15 divided by 3.25, and that will also give you this as well. Okay, so just remember money always goes on top. All right, so anytime you have money, put it on top, put it in your numerator. Alrighty, so Mark is working on a glass mosaic in art class and is only using rectangular pieces for the project. For each piece of glass, Mark wants the width to length ratio. Okay, so width to length ratio to be 1 1/4 to 2.5 inches. Okay, calculate the unit rate to the pieces and use that information to determine which of the following statements are true. Select 2 that apply. Okay. So what I'm going to do here is I'm going to take these ratios and I'm going to just divide them. Okay, so when I take this 1 1/4 and this 2.5, right, I'm going to convert those to decimals. 1.25 over 2.5. Now, what I'm going to do is I'm going to just divide these straight down. Okay, so I'm going to clear this, and I'm going to do 1.25 divided by 2.5. Right, and what happens is I get a half here, which means that 0.5 over 1. So what I did was this. I divided by 2.5, and then I divided by 2.5, which means that the width is half of the length. So for every 1 length, I should have half of the width. Right, so the width is 0.5 or 1/2, and the length is 1. Okay, so this means that the length is longer, which means I want to look for examples where the length is longer. Okay, so let's see, this one piece has dimensions of 1 3/4 inches long and 3.5 inches wide. Well, the width is longer here, so this cannot be true. I'm going to fix a typo down here really quick because I remember I forgot to change it. Okay. Mark found a piece of glass with a width of 3.5 inches. Since it has a length of 6 inches, Mark did not use it in his mosaic. Oh, I see what I did. Okay. Let's see. I will erase my typo. I forgot to read the question all the way. Sorry, guys. Okay. So this width is smaller than the length, right? But half of 6 is 3. So since these two do not match the ratio, it says that Mark did not use it in his mosaic. So he didn't use it because it didn't match the right ratio, right? So that is true. The question is asking which of the following statements are true. So that's true. Mark did not use it. If Mark wants the total length of his mosaic to be 2 feet, this will make the width of his mosaic 1 foot, right? His length is 2 and his width is 1. Perfect. And the last one here, right? If the length is 4.5 and the width is 9, remember you need the length to be bigger. Since this length is smaller, it cannot be D. Okay. So one of the ways that's kind of easier to break this problem down, you guys, is once you make this ratio, right, your width to length, and then your 1 1/4 and 2 1/2 or whatever fractions you have, see which fraction is bigger. That tells you that that length needs to be larger than the other. All right, so Jack and Jill decide to run to a basketball court after school. The basketball court is 4, whoops. I wish I could control Z, I can't. I have to come over here to the eraser every time. Is 4.5 miles from school. They run at a pace of 3 3/8 miles per hour. Enter the length of time in hours that it will take for the to arrive at the basketball court. Okay, so what you do here, first thing I'm going to do is take both of these and change them into improper fractions. So 4 times 2 is 8 plus 1 is 9 over 2 miles. And 3 times 8 is 24, 25, 26, 27 over 8. And this is miles per hour. So what you're going to do once you have your two ratios, right? This 4.5 came first, so my 4.5 is coming first here. You are just going to divide them. Okay, so when I go to my calculator over here, I'm going to hit this fraction button, do 9 over 2. Now, see how my cursor is next to the 2? I need to hit the right arrow to make it go in front. You have to do that, otherwise you will not get the right answer. So remember to move your cursor. Then divide it by the other fraction, which is 27 over 8, and you get this long decimal. Now, I need a fraction, right? So if I hit convert to fraction, it will give me 4 over 3. Right? So that means that this is equal to 4 over 3, which is 1 1/3. This is 1 1/3 hours. So remember, whenever you see this problem, take your first fraction you see and divide it by the second. Okay. Alrighty, does this graph show a proportional relationship? Well, let's see. For something to be proportional, it has to be a straight line, and it has to go through the origin. Now, the origin is down here. The origin is 0.00. Okay, right here. Now, this line is straight, but it does not go through the origin. So it cannot be yes, because it is not. So let's see, no, because the line does not give a y value for every x value. That's not true because it does. No, because the line does not go through the origin. This one, because the line does not go through the origin. C. Which of the following graphs represents a proportional relationship? Well, remember the line has to be straight. It has to have a straight line, and it must go through the origin. Right, so this is curved. Can't be it. This is a straight line, and it goes through the origin, right? The center part right here. So that's true. This line is straight, does not go through the origin. This line is straight, also does not go through the origin. Right? So for these problems, the only thing you're looking for is straight line, and it goes through the origin. That's it. Okay, guys? Easy peasy. All right, what is the number of minutes on the phone to number of phone calls routed? So whenever you have these problems, you need to pick a point, right? So you see our line on this graph. You are going to follow this line until you get to a point to where it touches an intersection. See how all these grid lines have these intersections where your y and x grid lines meet? You need to pick a point where your line goes exactly through the middle of one of those. Okay, so if I look at this grid line, it touches it, but it's not in the center. It's not in the intersection, not in the intersection, but here it is. Okay, so what you do once you have this is from this point all the way down, right, I hit a 10. 10 is my x value. From this point all the way to the left, right, I hit 40. 40 is my y. The reason why you want to pick a point where it touches the intersection exactly is because you know what those exact coordinate pairs are. If you don't, like if you were to pick this number and follow it down, there's no number, so you'd have to guess. Okay, so always be sure, don't guess. Right, now remember, k is y over x. K is your constant of proportionality. Okay, so this is y, this is x, so I have 40 over 10, which is the same as 4 over 1, which is the same as 40 minutes per call. All right, here's another one. Now, this graph, it just gives us different points, right? So point, 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 point. However, you still want to pick a point that goes directly in the center of each of the grid line intersections. So this is a little off. This one's way off. This one's also way off. This one's a little bit above, but this one out here is directly in the center. So if I take this point and follow it all the way down, I have 10. That is my x. If I take this point, go all the way to the left till I touch my y-axis, I hit 70. Right, remember x and y, and k is y over x. So this is 70 over 10, which gives you 7 over 1. So it is $7 for every hour of parking. Okay. In September, Lily planted a tree. Every month, the tree Lily planted grows 3 inches. If Lily plotted the tree's growth with the month on the x-axis and the growth on the y-axis, what would the constant of proportionality of the line be? Remember, time always goes on bottom. Time is months in this case, because we're talking about months, right? And your numerator is going to be how much it grew. So this is the inches, right? It grew 3 inches every 1 month. So this should be 3. Perfect. All right, so the graph shows the cost of magnets. Okay, this graph again does not have dots for us, so it's up to us to pick the right point. So if I follow this line, nope, that doesn't go in the intersection. Not in the intersection. Not quite yet. Oh, this one right here. This one right here. This goes in the intersection. So if I follow this straight down, my x is 2. And follow this straight across, my y is 3. Right, so this is x comma y. Remember, it is y over x. That is your constant. All right, so 3 over 2, which is 1.50 over 1. So it is $1.50. You could also double check this by looking at your graph, guys. So if I look at my graph at 1, right, 1 the line touches right here. If I go all the way across, it is about 150. But do not use that to know for certain. Use a point to double check. But this is a way you can check your answer. All right, which table shows a proportional relationship? All right, well, if I have 10 times 2, right, if I multiply 10 times 2, that gives me 20. If I do 15 times 2, that gives me 30. This needs to be 40. Sorry, I messed up. If I do 20 times 2, that gives me 40. So since each of my x's, right, because it's x and y, each of my x values is being multiplied by the same number, so this table A is proportional. Let's look here. If I have 10 divided by 2, that gets me 5. 15 divided by 2 is not 10, so this one does not work. 5 times 3 is 15. 7 times 3 is not 17. This one does not work. Now, 5 goes to 3. I can't really divide this evenly or multiply it, and I can't do that with any of the numbers. So D is also not an option. So also, in case you guys were curious, I was just looking at 10 to 20, and I was thinking, with multiplication or division, what number do I multiply or divide by to go from 10 to 20? Right, and 20 is doubled, so I'm like, well, you're multiplying by 2, so you can check that with the rest. Remember, for it to be proportional, you have to either multiply or divide by the same number, all the way down. All right, same question. If you ever have a 0-0 pair, that's like a free giveaway. Okay, so just take it, just ignore that one. Remember, it is y over x, right? It's y over x, which means that the ratio for this problem here is actually 12 over 2, which is 6. If I look at this next one, that is 20 over 4, which is 5. So those are not the same, so it can't be A. If I look here, I have negative 6 over negative 2. That is 3. If I have negative 3 over negative 1, that is 3. 0, 0 is a gimme, so move on. And 3 over 1, that is 3. B is 1. Now, since I have a 0 with another number that is not 0, this is an automatic no. And the reason why is because this. If I were to graph point 0, 5, right here, 0, I have 1, 2, 3, 4, 5, right? That means that my starting point for my graph is way up here. So my graph is going to look something like this. Now, it might be a straight line. However, it does not start at the origin, so it cannot be proportional. So no. So if you ever have a 0 with another number, that's a dead giveaway. That's an automatic no. Okay, which means that this one down here should be proportional, right? If I have 18 over 3, that is 6. I have 30 over 5, that is 6. 42 over 7, that is 6. And 54 over 9, that is also 6. It says select 2, so make sure you read it carefully. So there should have been 2 right ones, which we found. All right. Which of the following statements about the price of cribs are true if the price remains proportional to the numbers? So we have this table over here that talks about cribs, right? Here's a coordinate pair. Let's find the unit rate. So what I want to do is figure out how much it costs for every 1 crib, right? Well, if it costs $640 for 5 cribs, and I want to know how much it costs for 1, I'm going to divide by 5 on top and divide by 5 on bottom. Okay, so in my calculator, I'm typing in 640 divided by 5, and I get $128. Okay, so since it's $128 for every crib, for 1 crib, right? If I buy 25 cribs, I'm paying $128 25 times. So what you're going to do for all of these is take your unit rate price, this $128 or whatever price you find on your exam, and multiply it by the number of cribs that this person is buying. Okay, so if someone is buying 25 cribs and each of them cost $128, you're just going to multiply it. So 25 times 128, I get 3,200. Now, these two numbers are not the same, so A is not 1. If I do 8 times 128, 8 times 128, I get 1,024. B is not one of them. For C, I do 50 times 128. 50 times 128, that is 6,400. These are the same. C is 1. All right, I have 200 times 128. 200 times 128, I get 25600. That is not one of them. Let's try this. 90 times 128. So I forgot to write 128. And when I do that, I get 11,520. These are the same, so E is 1. Now it says to only select 2, but let's just double check this last one, just because, I mean, we're just typing this into a calculator, right? It takes us hardly any time at all. And I get 5760, so it cannot be that. Okay, so again, for this type of question, all you're doing is finding the unit rate and then multiplying it by the number of cribs that you're buying. All right, we have this table. It's asked us to find the constant of proportionality. Remember, you read from top to bottom, so it is x and then y. Right? When you write your rate, it is y over x. So if I use this first point here, I need to write my money on top. Money always goes on top, okay, over 2. So if I need to go to 1, divide by 2, divide by 2. So 28.50 divided by 2. And I get 1425. Okay? Remember, constant of proportionality is the same thing as unit rate. So whenever you see this, it's just literally asking you for the unit rates. All right, that's all it's asking for. So if you know that 2 hours, you get $28.50. If you get 1 hour, you should get half of this, right? Because half of 2 hours is 1 hour. So do not pick this one. Okay, that's way too much. This is way too little. If I'm working for 2 hours, 2 times 5 is not $28.50, so it cannot be that one. And this one right here, a lot of you guys like to pick this option. You just think about it, right? If I'm working 1 less hour, right, if I'm going from 2 to 1, I'm dividing by 2. So 28.5 divided by 2 is not 26.5. That's way too high. Okay. Which of the following equations represents a proportional relationship? For these ones, all you're doing is simplifying your fractions. Whenever there's an x attached up top, please just ignore it. It does not affect how you solve this problem. All that you're looking for is the numbers. However, whenever you have just an x with no number attached to it, there's an invisible 1, right? Because 1 times anything is itself. So 1 times x is just x. So here, if I have 3 over 15 equal to 1 over 15, right? The denominators are the same, but the numerators are not. So these are not proportional. If I look at b, right, I have 4 over 8, which is 1/2, over 8 over 2, which is 2. These are not the same, not proportional. If I look at c, 7 over 13 can't be simplified, but 2 over 26 can, because they're both even. I can divide both of them by 2 and get 1 over 13. Those are not the same. So if I look down here, 2 over 10, I can divide both of those by 2 and get 1 over 5. 3 over 15, I can divide both of those by 3 and get 1 over 5. So these are the same. Now, if you just ignored the x's, right, and only looked at the numbers, you would get 1 over 5 equals 1 over 5, which is the same thing. And since they're equal to each other, it is proportional. Okay, so if you're freaking out about the x's, just ignore them because they don't change how you solve the problem. All right, here we have this a lot of words explaining how Carlos says that the number of text messages he sends is proportional to the amount he owes on his monthly bill. Okay, so what that means is that he says every text message that he sends is the same price every single month. The question is saying which of the following methods could help Carlos prove his claim? Select all that apply. So what you want to do here is think about ways that we have been determining whether or not something is proportional. Remember, if you have a graph that starts at the origin and is a straight line, it's proportional. We have been doing a lot with tables, right? A lot with tables with our x's and y's, and if they all have the same rate or the same unit rate, then they are proportional. So what you want to do here is pick the two options that talk about either creating a graph or creating a table. Right, so this is Carlos could plot data points. If you're plotting data points on a graph, that is one. This is that he could divide the amount he owed in April by the number of text messages sent in April. Well, that's only giving us the unit rate for April, right? That doesn't tell us anything about any of the other months, so it can't be B. And it says Carlos could create a table. Perfect. And Carlos could create an equation. Well, equations really only need to have 1 month in order to write that equation. So that is not the best representation. So again, you want to pick one talking about a graph, talking about a table. Graph and table. All right, Georgie soccer team is selling 4 raffle tickets for $6. Guys, this problem, a lot of you guys are going to miss, and it's because you're going to write it like this. Do not write it like this. Remember, money always goes on top. All right, so do not write it like this. It should be $6 over 4 tickets. Okay, so whenever you divide by 4, 6 divided by 4 is 1.5, or since we're talking about money, it is $1.50 per ticket. All right, please remember money always goes on top. All right, the school store sells 2 pencils for 45 cents. What is the constant of proportionality for cents per pencil? Okay, now, this is a tricky one because it writes the money like this, 45 cents. Okay, so this is 0.45. Right, we're talking about 45 cents for every 2 pencils. I want to know what's the constant of proportionality of cents per pencil. So for every one pencil, how much does it cost? I'm going to divide by 2 and divide by 2. Right, when I divide by 2 here, I get 22.5 cents per pencil. Right, so since our question asked it like this, you want to pick this one. Right, it is 22.5 cents per pencil. Okay. So remember, money always goes on top. A deli sells 2 hot dogs for $3.75. What is the constant of proportionality of dollars per hot dog? Remember, money, again, always goes on top. $3.75 divided by 2 hot dogs. So I'm going to divide by 2 and divide by 2. When I take $3.75 and divide it by 2, I get $1.88. So I think I accidentally made a typo here, and let's make this one the 88 cents. I apologize, that was my fault. But this is how you solve it. Okay, it cannot be 40 cents per hot dog, please do not pick that. And it is not $3.75 per hot dog, please do not pick that, because that is how much it is for 2. Okay, so think about your answers here. All right, a company is looking to hire a receptionist and asks 2 candidates to submit their typing speed. Mr. Bean can type 620 words in 15 minutes, and Mr. Potter can type 840 words in 20 minutes. If the company chooses a candidate based on only who can type faster, which candidate should they choose? All right, so we have Mr. Beans here. He can type 620 words in 15 minutes. And we have Mr. Potter here. He can type 840 words in 20 minutes. Right, if I want to know how much each of them can type in 1 minute, divide this by 20, so 840 divided by 20. So Mr. Potter here can type 42 words per minute. That's pretty fast. And let's see about Mr. Bean. Divide top and bottom by 15, 620 divided by 15. See, I get 41.3 repeating. So Mr. Potter can type a little bit faster. So that means that Mr. Potter will get the job because he can type faster, right? 42 is larger than 41.3. All right, same type of question. A high school wants to hire a band to play music at its spring dance. The band name The Kids charges $1,800 to play music for $4, and the band name The Krills charges $1,425 to play music for 3 hours. Which band has the best price per hour? All right, so let's look at the kids here. Okay, so they charge $1,800 for 4 hours. Remember, money always goes on top, guys. Money is always on top. And divide by 4. So if I do 1,800 divided by 4, this is 450. Now, if we do the Krills, okay, they charge $1,425 every 3 hours. So if I want to know how much they charge for every one, right? 1,425 divided by 3, and they charge $475 per hour. So since the kids are cheaper, right? 450 is less than 475. The kids have the best price per hour. Oh, that's it. Awesome. All right, so that's all the review that I have for you guys for exam 2. Your exam is on Thursday, September 12th. Make sure that you also remember to submit your project. That is due Friday, September 13th. Okay, I did send out a video for the project, so check through your messages if you might have missed it. It is incredibly helpful. I would highly recommend watching it. If you have questions or if you take exam 2 and would like to have a retake or would like to try again, please let me know. Other than that, I hope you guys have a wonderful Wednesday.